Hi, so I'll be going over the umpire process for search for a range. So in the understand step, so our input is a sorted array of integers. And that's A. And then we also have given integer B. And for our output, you want to return a two-size array with the starting position of B in A and the ending position of B in A. And starting and ending position B and A. And so for some examples, so a two-size array with starting and ending position of B and A. If B is not found in A, we want to return -1, -1. So let's see. So some example inputs. So for example, for given A equals 5, 7, 7, 8, 8, 10, and B equals 8, our output should be, let's see, 0, 1, 2, should be 3, 4. Because it starts at 3, 0, 1, 2, 3, and ends at 4. And then for given A equals 5, 17, 100, and 111, and B equals 3, then our output should be -1, -1 because B is not in A. And yeah, that's correct. Okay. So for a match, I don't think I've seen this problem before, but you know, I've seen problems where you like search for elements in an array. I mean, this would probably use pointers, right? So using pointers. So I have seen those kind of problems before, but I don't think I've seen this problem before, and I don't think I really have a solution that I could use for it. So let's see. So in terms of planning, so we want, so since our algorithm's runtime complexity must be in order of O log n, so in order to make it O log n, I think we have to use like a binary search algorithm. So so I think we should create two functions that search the left and right of the array for the starting and the end position of our range for our target. So we'll create a function that searches the left part of the array. So to do that, we'll need two variables, right? So two variables, one equals 0 and another equals the end of the array. And then we'll use a loop that keeps going while So we use a loop that keeps going while our left variable, so yeah, we're trying to look through the left part of the array. So our left variable and our right variable. So we use a loop that keeps going while our left variable is less than our right variable. And then so we'll look at the middle of the array. So so we'll check the middle of the array, and then if that element is our target, we want our right variable to equal the middle. So we're like creating pointers, right? We're creating pointers, so we want the right variable to equal the middle minus 1. And then otherwise, if that element is less than our target, then you want to increase. You want to have our left variable. We'll say left variable equal the middle plus 1. Otherwise, we want our right variable to equal the middle minus 1. Okay, then we'll do the same thing for the right. So this function searches the left part of our array, and then this one searches the right. So it creates a function that searches the right part of our array. And then so we'll pretty much do the same thing. So do the same thing, but the difference is that so if our middle equals our target, then we want to increase to have our left variable equal the middle plus 1. If our middle element, so we're looking at elements, middle element is less than our target, then we want we'll have our left variable equal the middle plus 1. Otherwise, we'll have our right variable equal the middle minus 1. And then so this one, so at the end of this one, we want to return our left variable, and this one we want to return our right variable. Return our right variable. And this allows us to search for where the first index of our target and the last index of our target. So then we'll have our start variable equal the results of the left function, and then end variable equals the results of the right function. And then we just want to do a final check. So if our start variable is less than our end, we want to return our range. Otherwise, we want to return -1, -1. All right. And so we're in the implement stage now. So implement. So we'll define our left search function first. So I'll call it left search. We're just searching the left part of the array for our smallest starting index. So our starting index, I guess. I shouldn't say smallest, but yeah, well, we're just looking for our starting index. So we'll define our left search. So left equals 0, right equals the end of our array. And then this loop will keep going while left is less than or equal to right. So we first look at the middle. So middle equals left plus right divided by 2. Then so if our middle element is equal to b, our target, then our right variable will equal the middle -1. Otherwise, if it's less than our target, the element we look at is less than our target, then our left will equal to our middle +1. Otherwise, our right will equal our middle -1. And then we just want to turn lefts. So we find our starting index for our range through this function. Define right search. So we can just call it right search. And then so left equals 0. So we're doing the same thing. And then a -1. Then while our left variable is less than or equal to our right variable, we'll look at the middle element again, right? Left plus right divided by 2. And if the element there, oh, I put middle, but it should be, just forgot to write it out. So if that element is equal to our target, then we want to increase our left pointer to equal the middle +1. Otherwise, if the element there is less than our target, then you want to increase left to equal the middle +1 again. But if it's larger or anything else, then our right variable will equal our middle variable -1. Then in this case, we want to return right. We're searching for the ending index of our range. And so our start, we can have a start variable that equals the left search function. So we find the start of the range, this function, and then we have an ending variable. We call it end, and it equals the right search part of the function. So if our starting variable is less than our end, then we'll just return that range. Otherwise, I think they should be starting or less than equal to. Then we just return that range. Otherwise, we just want to return -1, -1. And then we didn't find the target in our array. Okay, let's see. Let's see. Oh, abbreviated again, looks like. Oh yeah. Okay, let's try again. So I got all the running test cases. Nice. And test the submission. Yeah, so it looks like it works. So yeah, I had to do some modifying for this, but I believe the time is O log n because it uses the binary search algorithm, and then the space I believe is O1 because we just have like constant space. I mean, we have our start and our end variables, but it won't really, these variables don't change depending on the size of our input or anything like that, so it comes out to O of 1. So thank you, that's my Umpire process for search for a range.